Hi everybody, today we're going to have a look at spanning trees and how to solve them using Prim's algorithm. So a spanning tree is a tree that takes a network and reduces it to, it's a weighted tree, reduces it to the minimum distance between each of the nodes. So by identifying the edges that will allow that. So using Prim's algorithm, we pick a node, find its nearest neighbor, connect the nodes, and then repeat until all the nodes are connected each time, just connecting the closest neighbor to the ones that we've already picked. There's an alternative to that. It's called Kruskal's algorithm, and instead of working with nodes, we work with edges. You're welcome to investigate that, but I won't be doing that today. So here is a network. I grabbed it off the net from somewhere, and we'll pick a node, any node. So let's, for the sake of argument, we'll pick A. I'm just going to change this to red so we can find them. We'll choose A. Here it is here. Now the shortest path from A to any other node is C. So we're going to use this one first. Now we're going to look at both A and C. I don't need to really color in the nodes. You get the idea. A and C are online. Now we look at the minimum path from A and C, and we can see that the next edge here is 14. Here we go. So now A, C, and F are online. We've connected them up already. And now we're going to look at the smallest path from either A, C, or F, which would give us this one here, the 6. Oh, no, it's not. It's 5. You have to be careful with this. It's easy to make a mistake. Now that A, C, F, and I are online, we look for the nearest one to that, and it happens to be this one here, this 1. So now we're going to look from A, C, F, I, and J, I and G. I think it's 4, so we're going to do this 4 one here. And the next one's going to be 2. And then we look from at A, C, F, I, G, H, and J. And the next one I think is going to be 6. Should be this one over here. Oh no, it's going to be 3. And from G we can get to that, to D. Each time we're trying to connect up a new node. Okay, now from here, the next one is going to be, we've already connected this, so we don't need to do that one. It'll be this one up here. And then the next one will be 12. And there we go. We can now get from A to J over the minimum roads required by having them all connected. We don't have extra roads. That may make the journey shorter for particular parts, but it will connect up everybody for the minimum amount of roads required. Easy. So we can do that with a table. It's the same algorithm, just thought about a different way. So the first thing we do is we pick a node. So let's pick A again and look for the minimum and cross out the others. And we'll bring A and C online, and we're going to cross out A as well. Okay, then we're going to look at the A column and the C column and look for the smallest number, which in this case will be 14. Cross out that whole row and bring F online. Now we're going to look at all the paths that lead from A, C, and F, and the next one would be 5, which would be this one. Cross all that out and look for I. That's my dog, Shush Ollie. Now look at A, C, F, and I. We've got this one path. And what you should be noting is that it follows the exact same path that we did when we were doing it on the graph itself. You have to remember to put G in. Now we're looking at A, C, F, G, and I. The next one will be this 3 here. Cross all of them out. Bring D on. Now we're going to look at A, C, D, F, G, and I. And the next one's going to be, so there's this 4 over here. Cross all of that out. And that brings H on. That identifies this 2 down here. Cross all of that out. Bring on J. So now we're just looking at who's not on. We've got a 12 here, nothing much here, 20 there, a 13 here, 15, oh, there's 7 up here. Let's bring B on. And then we're looking for one more. What's the minimum? It'll be this 12. And if I've done it correctly, these connections, B to D, A to C, D to E, C to F, so on and so forth, should be exactly what we found before. The same algorithm, just doing it with a table. And that's all I have to show you. Just remember that each time that you bring a node online, to put an arrow to indicate that you have to check it next time. And that's all I have to do. So thank you, everybody.